Space travel ignites imagination, but the idea of actually living on other planets has always felt pretty far-fetched. Until now, faced with unprecedented challenges here on Earth, NASA are exploring ways to actually build on Mars. But how would we get to this planet, let alone build there? This incredible proposal holds many of the answers, along with some lessons for building right here on our own planet. Mars is our closest habitable planet, and taking a manned mission there is seen by experts as our next achievable goal in space exploration. A human presence on Mars would enable us to learn more about the universe, gain a better understanding of our own planet, and search for extraterrestrial life. In recent years, encouraging progress has been made towards this goal, both by NASA and by other organisations such as SpaceX and the European Space Agency. But reaching the Red Planet and building the environments that are essential for any manned voyage there is an extreme undertaking. To help, NASA invited teams of innovators to submit ideas, stipulating that designs must include 3D printing technology that would use the harsh Martian terrain or regolith as a building material for the base. One of the leading ideas is this unique human-centric habitation concept that was submitted by international design practice Hassel in partnership with engineering firm Eckersley O'Callaghan. Here, our future settlers would thrive rather than simply survive. To learn more about the plans and how they would actually work in practice, I met Xavier de Kesteler, Head of Design, Technology and Innovation at Hassel, who masterminded the concept.
We're here at the Design Museum in London at the Mars exhibition. I mean, what is this? How did it come about?
Well, this is an exhibition, it's called Moving to Mars. It's all about how humans will move to Mars, but from a design perspective. We've been working with lots of scientists and engineers to make sure that our design is not just science fiction. It's actually pretty realistic. We only use technology that is existing today or will become very mature in probably the next 5 or 10 years.
Building a settlement like this, in a place where no human has ever been before, is a serious challenge. As each kilogram of equipment is expected to be hugely expensive to transport to Mars, NASA's preferred strategy is for structures to be 3D printed using material from the local environment.
Earth has this beautiful magnetic sphere that protects us from solar and cosmic radiation. Mars is magnetically dead, so which means all the radiation hits the planet and will hit our astronauts. The way you protect yourself from radiation is using a lot of mass. So the ideal thing would be going into a cave. So what we're doing is we're creating our own cave.
Working from London and San Francisco, Hassel developed an external shell which could be made entirely from Martian soil by autonomous robots equipped with advanced cameras and sensors.
We're actually looking at designing specific types of robots to do this task. If we get a robot over to Mars, what might happen if one of the two of them fail, there it is, you can't get a replacement part. So what we do, we're sending loads of small robots that kind of work together in building this structure. Think of it like this, an ant's nest, right? They build the ant's nest. If I would take half of the ants away, the ant's nest would still get built. Maybe a bit slower. Same thing here. If not all our robots arrive on Mars, they'll still be able to get built. It will take just a bit longer.
So what's the next step? I mean, robots have made it to Mars, they've built these cave structures for us. At what point do humans go there and what part do they play?
Well, it'll take a few years before the shell structure is built. Then the astronauts will come. They will also bring their habitat pods. So they'll bring these kind of inflatable structures. Because remember, going to Mars, you're not going to bring heavy stuff or big stuff with you. So we're going to bring inflatable, collapsible structures with us. And those will be inflated, and those will actually have the atmosphere and the pressurized environment that the astronauts will live in.
With the build phase complete, the robots would take on new roles, such as scouting for new locations.
So I mean, the way this proposal's been brought to life is just amazing. What kind of software did you use for animations and graphics and things?
What we've done, we actually worked with Epic Games and Unreal to create this real-time environment. So what you see here in the back of us is a real-time environment showing life through on Mars through a whole 24 hours. We've speeded up a little bit because otherwise it would take too long, but you'll see it goes day and night and so forth. All done by a company called Lightfield in real time with Unreal Engine. And it helped us also to kind of make really tiny adjustments all the time. So we were able to kind of move the robots, change the lighting, because we were working until such a kind of tight deadline, we had to be able to kind of use the real-time engine to be able to do that.
The environments that many of us associate with space travel tend to favour functionality above all else, prioritising performance and equipment efficiency over human amenities. But Hassel's design turns this convention around and creates a habitat where the crew can live and work in comfort and safety in familiar surroundings, without sacrificing the essential practical elements that a Mars base requires.
What we have here is our rack system. They're all identical in shape, but the infill is always slightly different. Okay. Right? So let's go into, for example, the lab one. And what I can do, I can open it up. I can just now step into my lab, do the experiments. On the left here, I have a workshop with 3D printer, even a sewing machine if we need to fix stuff. And once it's all done, I can close it up again and use other parts of the habitat.
The astronauts will be able to repurpose as much waste material as possible, from 3D printing spare parts and tools to making clothes out of landing parachutes.
Imagine the astronauts, they were having lots of waste plastics and waste material from food packaging, from science experiments. So we're thinking to reuse that and recycle it and use that to 3D print furniture.
I mean, it looks really stylish as well. It doesn't look like furniture that's been 3D printed by a robot. It actually looks quite appealing.
Well, it's been designed by a friend of ours, Manuel Jimenez Garcia, and it's printed in his factory in Spain. So we actually used recycled plastics, and all of these are 3D printed and designed specifically for the 3D printing process.
What have you learned from this that can be applied back home?
I've learned a lot about circular economy and sustainability doing this project. And you might think, well, designing something on Mars, that's not sustainable. That might not be on its own sustainable. To be able to survive and thrive in an environment like that, we have to think about sustainability on every single level. That way you really start thinking on how precious really our own environment is, how precious our own Earth is.
So I mean, this has got to be one of the coolest projects I've ever come across. What's it been like to work on it?
It's been really interesting, right? Especially as an architect, designing a really technical space. And I hope it actually shows when you compare this space to, for example, the International Space Station, that's purely done by engineers, that it really shows the skill and the need for architects to be involved in really complicated engineering projects as well. As a designer, be just brave and realize that our skill is really necessary and needed in a whole range of different types of projects.
While many technological, financial and political challenges must be overcome before the first manned mission to Mars, this remarkable concept, brought to life in such a compelling way, makes the prospect seem much more feasible.